All right, I'm back. I am going to run through the Linux shell lab real quick. And I'm not going to go very slow, but I'm going to answer the questions for each log file. I'm going to do my best to do it one time, and then we'll sort of figure out what we need to adjust for all the other log files. So I'm going to go ahead and log in, Callie. And then on the slides, you should see a command that looks like something like this. I'm going to go ahead and open up a new terminal by hitting Control-Alt-T. Zoom in. And maybe I didn't tell you this, you can paste with Control-Shift-V. So what I'm going to run is I'm going to run the wget command, which downloads something from a website. In this instance, it's downloading this file called linuxlogs.zip. And we're going to then run the command unzip linuxlogs.zip. So I'm going to hit enter. All right. And it did that really fast because it wasn't a super large file. It was like 2 megabytes or something to that effect. That's how much it downloaded, and then immediately went to unzip that file. So it looks like it created a folder called logs, inflated those, and we have the zip files. There was firewall test, elastic example, auth log.1, alhumite wraith at access, and then PDD 3 years access. I don't know what those things are exactly, but some of the questions that we have to ask are these. Boop, I'm going to copy them. And let's go here. I'm going to open code. We're going to do this in Notepad or text editor of some sort. Oops, text editor right there. All right. So we need to find which IP address shows the most, what commands were run, show all of the unique IP addresses, each IP only showing up once, and then show all of the unique user agents, which represents the the web browser IDs. So I don't know what is what in any of these things just yet. So what's the first thing we need to do? We can look at what's in the file. We can look at the first few lines by using the head command. I'm going to use head firewall. Oh, I'm sorry. I have to go into the logs folder first. CD logs, and then I can type head firewall, and I should be able to hit tab and then have it complete out for me. So this should show me like the first 5 or 10 lines. And you can see that these were apparently entries. Each one of these lines represents one entry into the log file, something that happened somewhere on this firewall test, right? This happened at December 3rd at 1840 and 1 second. So that'd be 6:40 in the evening in 1 second. Says session opened for user root. All right. And it looks like a minute later, it looks like authentication failure. So this is access on the firewall. Somebody logging in using SSH to the firewall. The reason I know it's SSH is because this is the program. So here's the format. This is a timestamp with the date. Now the timestamp format does not include years, so you need to just be mindful of that. So we don't know what year this is, but we know that this was December 3rd, and then the day, or I'm sorry, time of day. This is the host name that registered this log entry. In this instance, this firewall was maybe called example. And then we have I think the facility, which is what they call the program that is registering the log entry. And then this is like the content of the log entry here. So we can see there was an authentication failure by the user that was logged in via SSH. We can see that the R host was this person, the R host being remote host. This is the person that failed authentication as the user root. Okay. So we have 2 entries here. This one is important. It said failed password for root. So this wasn't a login attempt at, 6:40 and 59 seconds, and it failed login from this IP address via SSH. Let me do this. I'm going to open it up in Nano just so we can scroll around a little bit. And you can notice over here, this line isn't, it's not the entirety of it, right? There's more to that line. So what I can do, you can see my cursor jumping around on that line. If I hit the end key, notice that it sort of scrolls over, right? It carries over. So if you see that little indicator right there, know that there's more to that line to see. What am I doing first? I'm supposed to answer which IP address shows up the most. Okay, so if we look at some of the previous slides, I guess I have them over here. I might as well pull them over and show. My previous slides, we see we want to start counting things, right? We want things to keep. We want to sort and filter various things out. So we're looking at the log file in Nano. So let's start filtering by, or I guess maybe looking for IP addresses in there. So where does the IP address show up? Right there, or what is a thing we're looking for in an IP address? Does it show up anywhere like predictable? Our host is maybe predictable. From is maybe predictable. I don't know. So let's cat out the log file. Firewall. I'm just going to grep, and then I'm going to say our host equals. So that shows all the lines that contain only the words our host. You can see that that's kind of cumbersome. There's a lot like going on. The screen's messy. What if I showed only some information? I can use grep tech O to only show things that match our host. What happens? It only shows what I searched for in each line. Well, we can use these things called regular expressions. And I'm going to use a big E for only show the expression that matches this. And this is a little bit of an incantation. You're just going to have to learn regular expressions as you go, and you will only get good at them by doing them. The long and the short of it is that this will find everything. It will find, it must match our host equals, and then the period is like a wild card. And then the second part is called, so this is the character, and then this is the like count or quantifier. So how many times? Asterisk means 0 or more, one or more. So it will match any character one or more times until the end of a line, until that /n new line character. So let's see what this does. All right, so now we've got something a little more interesting that we can sort of tease apart. What was the question we were asking? We were asked about which IP address shows up the most. Okay, so let's change what it is we're looking for. We're going to look for everything, but we want to exclude this user root, right? This last part. I'm going to say a space at the end. I wonder if that'll do it. That got rid of all of them. Check this out. Now we can pass it through our pipeline. So there was a tool that we used. If we again look at our slides, we were supposed to find which IP address shows up the most. We're going to get a count for this. If we look at our slides again, top 10 of many things. Unique, the unique command, and then C will prevent the number of times that that particular line occurs. So let's do unique -C. Now notice we have a bunch of duplicates. I wonder why that is. Generally, you see something like this. We're building a pipeline right now. I'm passing the output of one command to another command rather than putting it on the screen. And then that last command is responsible for what ends up on the screen. A lot of times you have to see things like sorted in order for unique to truly catch things correctly for some reason. Let's see now. Yeah, I don't know why it does that. It's strange. I don't get it. We can see that 38 instances of this line. If I wanted to sort that again, based on that column, again, if we look at our slides, it's all in the slides, y'all. It's all in the slides. We can sort numerically and then reverse the order. So why did I say numeric and reverse? Again, remember that everything that's on the screen shows up. This is the shape of the number 1. This is the shape of the number 12, not the quantity 12, the shape that constitutes that represents the number 12. So what we have to do is tell it that the sort command to sort the first column, and it assumes the first column by default, so we don't have to say it, dash, we treat it as a number numerically. So let's see what happens. It does it, except it's in ascending order, and we want it in descending order because we want the highest numbers at the top, so we can sort of get a countdown. So we have to reverse that number. So what do? There's our answer right there. I'm going to copy selection. Which IP address shows up the most? So let's create one for each file. So firewall example. I'm sorry, firewall test.d 138. Okay, I'm going to, what's the next question? The next question was, what commands were run? Okay, so I need to look at the log and find out what a command looks like. Firewall underscore test auth log. I'm going to zoom out just a bit so I can see a little bit more. And then I'm just going to use like page down and kind of look in here, just looking, and hopefully we'll find a command. Somebody tries to run a command or something. Not every Linux machine is configured to log all of the commands that are run. Generally, anything that has to do with authentication, you will find a log entry for, but unless that person is running something as sudo, we won't see a log entry for it a lot of times by default. So let's do this. I'm going to look at what logs are around. I'm going to nano elastic. I'm just going to find what commands were run. We lucked out. Check this out. I just mentioned sudo. Here's sudo. I didn't know which one it was going to be. So we can see that there is a server listening on port 22. That's SSH. That's the SSHD process 1291, apparently, in the context of this computer. We can see that we had a successful connection for the Ubuntu user from this IP address using SSH. So public key authentication, just passwordless authentication. It is generally considered to be as secure, well, not as secure, more secure than like password. Just because it's passwordless or public key does not mean that it's less secure some way. Somehow it is, it's very secure. So what do we have? The sudo command, when you run it, by default, you sudo apt-get install something, you are authenticating. You have to provide your password generally. And this one is saying the sudo command on March 27th at 1:09 in the afternoon, the Ubuntu user ran a command as root. The command was user bin curl, and curl is just a tool to download something from a website. And it does something else. What did they do? I'm scrolling down, going over here. They downloaded a .deb file. Okay, so .deb file is just like it's like a installer for certain like Debian-based operating systems, Linux operating systems. So, all right. Then they run the sudo apt add key, or I'm sorry, apt key add right here. So we're looking and we see the kind of command, just like the rhost, I bet we can filter on command equals. I'm gonna go ahead and exit for the time being. And I'm going to cat, what was that? Elastic example auth.log. just to verify, we put it on the screen, we can see there. Let's build our pipeline. I'm going to grep for command equals. Let's see what happens. We got nothing. I told it to look for lowercase command, and it turns out, if I scroll up, hopefully I'll find one. If I scroll up, I'll find it's uppercase command is what we're looking for. Uppercase command. At any rate, let's do that. I'm going to say command equals. There we go. So remember our trick of showing with the regular expressions, we want to match everything command, any character, all the way to the end of the line. Now you notice the part that's highlighted in red, that's just the command. Excellent. But it's still kind of messy. So I want to only show that stuff. Only show the matched part. Very nice. Cool. All right, so what was the question we were even answering here? What commands were run? So I guess we've kind of already done that. We've looked at that. Let's do that same thing where we sort it, and then we just want to see unique lines, because it looks like this person, this user edited that file twice. We don't need to, I mean, we can look at it and sort of tell that's a useful timeline, but if we're just trying to find out what happened, and we're not destroying any evidence, we're just kind of filtering it in real time. So this is the unique set of commands that were installed. Now notice this command and this command look very similar, but capital D DNS mask is not the same as lowercase DNS mask. So when I told it to show unique lines, it doesn't know the difference. Well, I mean, it does know. That's why it showed 2 entries. There was likely just a typo on this user's thing. So how many different commands did that person run? I can run a word count for the number of lines. There were 83 different commands run. I'm just going to put that on here as our answer for Elastic. And there's always, you can ask these same questions. You could ask the IP question about this example auth.log. You could do the same thing. So Elastic, what was it? Elastic. Oops. And then there were 83 commands run. Let's go ahead and copy our command in there as well. I'm going to right click, copy selection, come over here. I'm going to paste it. That way I have notes for myself in the future. If I was trying to recreate my steps, I don't have to try to remember some of those things. I can just copy and paste the answer. So I'm going to copy the question. And I'm sort of you notice I'm putting sort of a hierarchy. All right, so I have file name, question I'm answering, answer to the question. All right, so let's look at show all of the unique IP addresses, each IP address only once. Okay, so let's look at another file. I think, what else is there? We'll just go left to right. All right, well, we already did that. Let's do Almhute Wraith. I don't know what that is. Nano Almhute Wraith access log. So, okay. So this was collected. This is a web server proxy, or I'm sorry, a web proxy log, I guess, or a web server's access log. It shows IP address, date, and then the HTTP verb of get, and then the path requested. So it also looks like it logs user agent. as well. Yeah, so it shows the HTTP request. This instance, it was a post request as opposed to a GET request. We have the status code of that request, the size of the response. I'm sorry, maybe the size of the response, and then the user agent. So I can tell that this request was made by a cell phone, probably because it's Android. Running Chrome, mobile Safari, yada yada. So okay, so the question we're answering is what? Show all of the unique IP addresses. So all of the IP addresses that potentially visited this web server. So let's do that. Alm Hewitt. Long. Fix that. All right, so let's start whittling this away. We know that the first column is what showed us. The first column is what showed us the IP address. This is the first column. So how do I do that? How do I show only the first column? Well, I can take the output and I can cut it up. Okay. So how do I do that? I take the output of the head command, I pass it to the cut program. I tell it that my delimiter, or the thing that separates columns, or not just columns, but columns of information, visually to humans, we're expecting it to be a space character. That's kind of intuitive for us. But the computer doesn't know or care. It could be colons, it could be commas, it could be semicolons, it could be the tab character, that /T. We're going to tell it that it's the space character, explicitly the space character. And the way we can do that is say cut-D for delimiter is a single quote, a space, and then another single quote. All right, so we're cutting on that, and we want to show a field. So we use F1. If I wanted to show the second field, let's see what would happen. I see a bunch of tick marks. If you notice, that's what's in the second column, tick marks. Again, if we're using spaces as the thing that identifies a column, what about the third field? More. What about the fourth field or the fifth field? Okay. What about the seventh field? Okay, that's interesting. So we've got potential URLs right here for us to look at. We know we're looking at the first field, though. That's what we want to see, IP addresses. Cool. So why do I only have 10? I told it to put it on the screen. I used a special program to put it on the screen. I used not cat, but head. Head, just for the sake of prototyping, this file could be gigabytes large, and it would take a lot longer to process. Head will allow me to work with a small, realistic subset of the data, the first 10 lines. So as long as the first 10 lines are a fair representation of the rest of the data, this is a fair way to sort of prototype it. We can run it on all of the data by using cat. So I'm going to put all of the file onto the screen, and I'm going to cut it up based on spaces, and I want to show the first column, the first field. What happens? You can see it's taking a lot longer now. Okay, cool deal. So what's our question? It says show all of the unique IP addresses, each IP only once. So you can see we have a lot of duplicate files, or I'm sorry, duplicate lines. This 130 address used this website a lot. So like the other commands, remember we can build that pipeline. Let's look at it. How do we build that pipeline? We want to sort it, and then we want to show unique entries. Sort-U. I think sort-U is going to be a shortcut for that. So that'll be nice. And so these are all of the unique IP addresses. I expect them to be unique, that access this particular web server. Oh man, that's a lot. So what's the question we want to ask? How many unique visitors did we have? Really, that's kind kind of a core question here. Another command we could use is word count based on the number of lines. We had almost 4,000, 3,886. So what I'm going to do is copy the selection. I'm going to paste my answer to that question. But the question of like which IP address shows up the most is really interesting as well for a website. Which place, which person is using the website the most? So I'm going to answer that question as well. If I go through my history, I'm going to be able to find it. Unique in R. So I think we can adapt this command, or a command like that actually. We can adapt that command, which shows up the most. We used, what did we do? Let's go back here. Sort -u unique tac C to count them. And then we want to, or actually, let's just, we want to sort them. We want to look at all the unique instances and we want to get a count. Remember that first column is going to be a number for the unique command. And then we want to sort again based on that first column because it's going to give it to us in ascending order. We need to treat that column as numeric and we want it reversed. Let's see. We have a bunch of one-off visits. Oh man, a bunch of one-off visits. We can make this easy on ourselves. Remember that head command. I can take only the top 10. Remember, as you pass things through the pipeline, the last program is responsible for what ends up on the screen. Head, we know by default, takes whatever you give it, in this instance, what was handed to it on the pipeline, and shows you only the first 10 lines by default. So it looks like there were 78,000 unique hits to this particular website from this IP address. What could that mean? This one IP address could service an entire building. So it's not just one person going to, facebook.com, but 10 people or 100 people going to Facebook from this one building's IP address. So don't make the mistake of thinking that one person could just visiting a website over and over all day. It could be that some application that they have, like listening to Spotify, like constantly it polls and it refreshes new information all the time. So it could be that, this is a single user doing something relatively benign, not time wasting or anything of that. So just context matters. What about this one here? Okay, let's see. Yeah, I don't know. I mean, it's just, here's the top 10. These are the most populous ones. That's all I can really say about that. So let's get all of our output, copy. We copy our answer and the answer, or how we get the answer, and then the answer itself. I'm going to select all of those and use the tab key to sort of push them over, just like you can in like a really nice text editor. So what was the last question we're going to answer? Show all of the unique user agents, web browser IDs. All right, so let's see. Is that last log file? Head. Yes, that's also a web server. Great. So I wanted to see which one of these, this file, I don't know what it is, PDD_3 years _access log. There's again some web server access logs. This IP address accessed it on 13th of January 2021 at 6:25 +8. So it's not at UTC time. So +8 is going to be, oh gosh, 8 hours plus GMT. We're GMT -6 in Central America. So they're going to be like somewhere in Middle East. I think that longitude. So I don't know. At any rate, what are we looking for? We're looking for the thing that identifies a web browser, and that's going to be called the user agent. Now, again, the nice thing about these log files is that they are well defined. I guess we have to look at another program here because I can't think of a way to use cut to do this nicely. We used cut in the last couple to sort of split things up based on spaces, but some of these things may have spaces, more spaces than others. So, oh man, this is terrible. I don't want to do that. Mozilla, this mobile. Is that all the user agent? Are those all the user agent? Yeah, they kind of are. Okay, let's do that. Let's just muscle through it. Head, PDD, 3 years. We're going to cut, and I think it'll assume a space is default. Let's see what happens. If I say F1, what happens? I guess it doesn't do anything. So I need to tell it that -D. We have to use the D space. We have to use that to say the delimiter is a space character. Maybe it's waiting on a tab character. Maybe that's it. So let's see. IP address, field 1. That's my IP addresses. Great. If I wanted to see the 1, 2, 3, 4, 5, 6, 7, 8, 9 columns, the 9th column should always be the user agent. Nope, I was wrong. I missed something in there. 1, 2, 3, 4, 5. We missed a space. 6, 7, 8, 9, 10, 11, 12. Okay. So yeah, that's not a great way to be sure that we're getting all of that stuff. Let's see. Is there a way? Now we're really figuring something out. This isn't like me with a pre-cooked turkey or anything. Column. Let's see. Let's put all of that in there. Let's research it, man. Google. I have a feeling it's going to tell us to use awk, and I really don't want us to use awk because it's not. It's like a domain-specific programming language specifically about parsing text. It's not great. Why is this thing slow? Okay. How do I get this? Oh, my mouse has stopped working. That's crazy. Oh man, well I can't do much without the mouse. Yeah, I can. Yeah, we can figure this out. Oh, no, see, the mouse is kind of working, but it's kind of not. That's what's crazy. All right, so let's go back here. Let's figure it out. Let's just do it without that. What's another way? I know that I want to match 2 quotes backing up to each other. What do I mean by that? Let's look at nano PDD, this. I'm looking, and I look at the line, I'm looking for something that's common between them. Between each line that has a user agent. And it looks like every line has a user agent because these are all the access logs, not the responses from the server, but what the server is being asked for. For some reason, like on this line here at the top, I see a pattern. The pattern I notice is that this quote and this quote show up as two separate columns. But everything to the right of this is the user agent. Again, the user agent is the thing that represents the string, which is kind of like uniquely identifying the mobile device. Or I'm sorry, not the mobile device, but the web browser accessing the website. This instance, it was a mobile device. I keep scrolling. It's telling you that this is a mobile device using WeChat, which is like a Chinese-based chat application. ARM64. It's an ARM mobile device, most likely net type Wi-Fi. So it hands all of this stuff over as part of like, hey, I am the client telling you a bit about myself so that you can tailor the experience you provide to me. It's kind of the same way that when you go to a website on your phone, you get automatically presented with a mobile experience. You have to tell it that you want the desktop experience. Part of that is because the server is able to identify, hey, this is a mobile device, partly because you're saying, this is my user agent. Your user agent carries a lot of identifying information such as Android, iPhone, something to that effect. So we see a bunch of Android things in there, or Mozilla Firefox, as I think some of them said. Let's find one that says iPhone. So here is one that says iPhone, like Mac OS X, Apple WebKit, runs all the way to the end, net type Wi-Fi language EN, okay? And those are two different devices, 219 and 241. Where I'm getting that is this IP address and that IP address. So you can't see my mouse all that well on there. I don't know why. That's craziness. What is this? Okay. What I was getting at was 219 and 241. Two wholly separate things. Okay, so I said all of that to say that when I see two quotes back to back, that's a lot of times going to be the user agent. I see already there's a problem with that algorithm that I designed in my mind, right? If I see quote, space, quote, everything to the right of that is going to be the user agent. There's a problem with that. Well, that actually might still be technically a user agent. Now I think about it. I was going to say this doesn't strike me as a user agent that I'm familiar with, but that doesn't, just because I'm not familiar with it doesn't mean it's not true, right? So I can research. I can find out what is this thing. Okay, let's see. Mozilla, this is all right. Let's see. Let's get out of here. Let's grab those. And I'm going to, what am I going to do? I'm going to grep for only things that match the regular expression. Or in here, I have to get tricky. I have to use a single quote rather than the double quotes because I'm looking for double quotes. So a single quote, double quote, space, double quote. And I want everything to the end of the line like this. Let's see how close that gets us. Pretty close, pretty close. We can see that some of these are coming through in English. Some of them are coming through in Chinese. Excellent. So let's run that over the entire file as opposed to just the first 10 results. Let's see what we get. A bunch of things. So again, I mentioned that if you have a phone that's from last year, its user agent, part of it, like you'll notice here, its user agent isn't going to be the same as a phone you necessarily get from this year. Because part of it is like sending the operating system version, and not all phones get operating system updates anymore, right? So you can use this as a way to fingerprint and uniquely identify people as targets or as, or would-be targets, things like that. So let's run that same sorting, filtering, top 10ing of things that we do. What did we do? We sorted all of the information first. Then we showed unique representations, and we specifically wanted to get a count of them. And then we wanted to sort that information based on the first column. Again, the last program in the pipeline is what's responsible for what ends up on the screen. So if I run this, what happens? I might see a bunch of like 1 equals 2 equals so on and so forth. I need to sort that information based on this first column that it gets. And that I need to treat it as a number numerically, and I want the top 10. Or actually, if I don't do this, I don't have to do the whole head thing at the end. If I just do this, it should fill my screen with a bunch of stuff. But this way, it's upside down, that hierarchy, I guess. But the most common one shows up on the end, at the end. Right? There's a bunch of different ways to do it. You could also, rather than using head, you could use tail. And that'll show you the last 10 lines of a file. Or whatever it was given. In this instance, the output of the pipeline. So we can see the most frequent was 2,077 instances of this browser. So what are some uniquely identifying things about this? iPhone OS 4.3, they have a very specific version of the web browser. The web browser will get updated more frequently than the base operating system. I don't know what this number represents necessarily, but it represents something. This is a specific application, micro messenger. And then this is giving us a very specific like version number. It might be that this application is updated maybe as frequently as the web browser. This code is, the people that write WebKit, very excellent upper echelon developers. Maybe that's not the case for micro messenger. So I don't know, this is like super speculation. Maybe this application is updated more frequently than others. You can see that here we're looking at version 7.021, and this is 7.020.1781, right? So this is one entry. This is a second entry. There are 2,183 people, or I'm sorry, instances of access to the web server using this version of the application. And then 2,700 using this version of the application. There could be any number of reasons. Maybe the same person updated the application and then went back to the website. Totally possible. Don't know. We could dig into the logs further and find out. But to get a lay of the land, there are far more people using iPhones to access this website. Oh, I'm sorry. Did I get that right? Yeah, there are more people using iPhones to access this website than anything else. There are people using Chrome web browsers. You can see that because part of the tail here, Chrome 87, they're straight up telling you that this is a desktop web browser. They're telling you it's coming from a Windows NT machine, Windows 10, version 64, 64-bit application. This is a 32-bit application. Likely. Let's see. I'm not sure exactly what this one represents. This one's kind of a catch-all URL, but let's see. At any rate, we've answered the question. Let's do that. Let's go ahead and commit it right here. Copy, selection. This is another 40-minute video, 45-minute video over nothing. So what was, it was PDD something. Okay, and then do, what was my question? Show all the unique user agents. Copy. Oops. Tab, paste, tab, right there. remember that whole hierarchy that I built out? File name, log, question that I'm answering, answer to the question. Okay, so I think that's that. That's kind of a nutshell, like what we were supposed to be doing with the whole accessing, like parsing access logs and like doing things with the command line. Why having an understanding of the tools can help you develop repeatable processes and automate some of your workflow, right? You can get an answer, like you can just drop in a new log file, doesn't matter what it is, get the same answers from some point in the future. So or from a historical perspective. So that's why learning the command line is useful, because it allows you to have more rapidly repeatable processes in place. All right, well, I'm going to leave it at that for the time being. If you have questions, comments, concerns, send me a message.